Hello. In this class, we will study the concepts that are important for kcet and NEET as far as the Coulomb's line electrostatics is concerned. See, we know that Coulomb's line electrostatics describes the force between 2-point charges. Coulomb's line electrostatics. This law mainly describes the force between 2-point charges, describes the force between 2-point charges and you must remember this Coulomb's law can be applied only for point charges at rest. It is applicable only for point charges at rest. And according to Coulomb's line electrostatics, if the two charges say Q1 and Q2, Q1 and Q2 are the two charges placed in vacuum at a separation, say R, then there exists a force between these two charges. We call the force between two charges as electric force, or we also call it as Coulomb force. Force between 2-point charges is called electric force, or we can also call it as Coulomb's force, right? And we know this Coulomb's force or electric force may be attractive or it may be repulsive. ಎರಡು ಲೈಕ್ ಚಾರ್ಜಸ್ ಇದ್ರೆ ಇದು ಪಾಸಿಟಿವ್ ಇದ್ರೆ ರಿಪೆಲ್ ಆಗ್ತವೆ, ಇದು ನೆಗೆಟಿವ್ ಇದ್ರೂ ರಿಪೆಲ್ ಆಗ್ತವೆ, ಇದು ಪಾಸಿಟಿವ್ ಇದು ನೆಗೆಟಿವ್ ಇದ್ರೆ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತವೆ. ಸೊ ದ Coulomb's force may be attractive or repulsive. The Coulomb's force may be attractive or it may also be repulsive. It depends upon the nature of the charges. If both the charges are like charges, there will be force of repulsion between them, and if both the charges are unlike charges, there will be force of attraction between them. Then, what is the magnitude of the force between the two charges? See, from Coulomb's line electrostatics, we know that force between Q1 and Q2 when placed in vacuum is given by force is found to be directly proportional to product of magnitude of the two charges. The force of attraction or repulsion between 2-point charges placed in vacuum is directly proportional to product under multiplication method, product of magnitude of two charges. They have put the magnitude symbol. ಅಂದ್ರೆ ಈ ಚಾರ್ಜ್ ಸೈನ್ ಏನಾದ್ರೂ ಇರಲಿ, ಇದು +2 ಕೂಲಂಬ್, ಇದು -5 ಕೂಲಂಬ್ ಅಂತ ಕೊಟ್ಟಿದ್ರೆ, suppose this is +2 ಕೂಲಂಬ್ and if this is -5 ಕೂಲಂಬ್. While calculating the force, you just take the magnitude of the charge. 2 into 5 ಅಂತ ಮಾಡ್ರಿ ಅಷ್ಟೇ, +2 into -5 ಬೇಕಾಗಿಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ. So the force between 2-point charges placed in vacuum is directly proportional to product of magnitude of the charges and inversely proportional to square of the distance between the charges, right? So force depends upon product of magnitude of the charges and it depends upon the square of the distance between the two charges. We write F is equals to K Q1 into Q2 divided by R square. I have told you K is Coulomb's constant. We have discussed about the nature of this Coulomb's constant. This Coulomb's constant depends upon This Coulomb's constant depends upon two quantities. One is system of units used. System of units used. See, ನಾವು ಯಾವ ಯೂನಿಟ್ಸ್ ನಾಗೆ ಫೋರ್ಸ್ ಮೆಜರ್ ಮಾಡ್ತಿದೀವಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ಕೆ ವ್ಯಾಲ್ಯೂ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಇಫ್ ಯು ಆರ್ ಮೆಜರಿಂಗ್ ಫೋರ್ಸ್ ಇನ್ CGS ಯೂನಿಟ್, the value of K will be different. If we are measuring force in SI system, the value of K will be different, right? So K depends upon the system of units used, right? Or we can say the value of K will be different in CGS unit and it will be different in SI units, right? So it depends upon system of units used, and also the value of K depends upon the medium in which charges are placed. The medium in which charges are placed. See, the value of K depends upon system of units used. ನೀವು ಯಾವ ಯೂನಿಟ್ಸ್ ಒಳಗೆ K ಮೆಜರ್ ಮಾಡ್ತಿದ್ದೀರಿ ಅನ್ನೋದ್ರ ಮೇಲೆ K ವ್ಯಾಲ್ಯೂ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. And also the value of K depends upon the medium in which charges are placed. See, in vacuum and in SI units. In vacuum and in SI units, the value of K is 1 by 4 pi epsilon naught. Medium specify ಮಾಡಿ ನೋಡ್ರಿ vacuum ಒಳಗೆ ಮತ್ತೆ SI units ಒಳಗೆ K value ಎಷ್ಟು ಅಂದ್ರೆ 1 by 4 pi epsilon naught. So force between two charges now becomes ಅದರ force ಏನಂತ ಬರೀಬಹುದು. Force between 2 point charges can now be written as F is equals to K can be replaced by 1 by 4 pi epsilon naught. K is 1 by 4 pi epsilon naught. Q1 into Q2. See, K 1 by 4 pi epsilon naught. Q1 Q2 divided by R square as it is. This is the force between 2 point charges placed in vacuum and evaluated in SI units. Right? So this is the formula for calculating force between 2 point charges in vacuum. Force between 2 point charges in vacuum. This is Coulomb's law of electrostatics. So Coulomb's law of electrostatics, the force between 2 point charges is directly proportional to product of magnitude of two charges and inversely proportional to square of the distance between the two charges. The proportionality constant is K and is called Coulomb's constant. It is found to depend upon system of units used and also it depends upon the medium in which the charges are placed. Right? In vacuum and in SI system, the value of K is given by 1 by 4 pi epsilon naught. Here, epsilon naught is called permittivity of free space. It is called permittivity of free space. Epsilon naught is called permittivity of free space and its value is 8.854 into 10 to the power of minus 12 farad per meter. Right? This is the SI unit of epsilon naught. We'll speak about SI unit of epsilon naught in detail again. Right? So this is regarding Coulomb's law of electrostatics. See, it is important to note the SI units of epsilon naught. SI unit of permittivity of free space is epsilon naught. ಇದರದ್ದು SI unit important ಯಾಕಂದ್ರೆ ಯೂನಿಟ್ಸ್ ಅಂಡ್ ಮೆಜರ್ಮೆಂಟ್ಸ್ ಆಗ್ತದಲ್ಲ ಅಲ್ಲಿಂದ ಈ ಕ್ವೆಶ್ಚನ್ ಕೇಳಬಹುದು. You know that F is equals to 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. Suppose I want the units of epsilon naught. I'll write the equation for epsilon naught. Epsilon naught can be written as 1 by 4 pi F. ಈ epsilon naught na LHS ಕಳಿಸ್ರಿ. F ನ denominator ತಗೊಂಡ್ರೆ 1 by 4 pi F Q1 into Q2 divided by R square. Right? ಹಾಗಾದ್ರೆ ಈ ಯೂನಿಟ್ಸ್ ನೋಡ್ರಿ 1 number as it is 4 ಯೂನಿಟ್ ಇಲ್ಲ 5 unit is a constant and F force is measured in Newton into charge is measured in Coulomb. The other charge Q2 is also measured in Coulomb divided by distance R is measured in meter. Distance square radrinda the unit will be meter square. So if we combine this, the SI unit for epsilon naught will be Coulomb square per meter square. Coulomb square per meter square per Newton. Coulomb square per meter square per Newton. Or this can also be written as farad per meter. This must be read as farad per meter. Right? We'll know what is farad in the next chapter, potential capacitance number. There we'll understand. Right? So this is regarding the SI unit of epsilon naught. Even use mathematics, you try to write the dimensional formula for it. Right? So this is regarding epsilon naught. Now we will try to understand more about Coulomb's force. The Coulomb's force again, one just important points of it that we'll try to understand. See, as far as Coulomb's force is concerned, Coulomb's force is a medium dependent force. It is a medium dependent force. That means the force between two charges. Coulomb's force is nothing but force between two charges. The force between two charges depends upon the medium in which the charges are placed. See, in vacuum, if the charges are placed in vacuum, the force between the two charges in vacuum will be Fv is equals to 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. This is force between 2 point charges when placed in vacuum. If the same 2 point charges are placed in, suppose Q1 and Q2 are the 2 point charges placed at a distance R in vacuum. Suppose the medium between two charges is now vacuum. Now the force between two charges can be calculated as 1 by approximate Q1 Q2 divided by R square. Suppose the same two charges, charges Q1 Q2 separated by same distance. Vacuum na distance is distance na charges Q1 Q2 na. If I happen to place in say water, I happen to place the same two charges Q1 Q2 at same separation in water, the force now changes. Force change charges were placed in vacuum. Now the same charges are placed in water. There is a change in medium. Medium change ಆಯ್ತು ಅಂತಂದ್ರೆ the force between the two charges also changes. Change ಆಗಿರುತ್ತದೆ. ಇವಾಗ the force between the two charges in medium, the force between two charges in medium, in this case water, will be given by F medium is equals to 1 by 4 pi epsilon naught K. Notice in air it was in air or vacuum. Vacuum under one, air under one. In air or vacuum, the force between two charges was 1 by 4 pi epsilon Q1 Q2 by R square. Whereas in medium, if the same two charges Q1 and Q2 are placed in medium, the force between the two charges will now be given by 1 by 4 pi epsilon naught K. Q1 into Q2 divided by R square. Q1 into Q2 divided by R square. Here, K is called dielectric constant. K is called dielectric constant of the medium. K is called dielectric constant of the medium. Now we call it as dielectric constant of the medium. The dielectric constant at this point of time, you just remember dielectric constant of medium actually decides by what factor the force is going to change. Decides the factor by which force between two charges changes. We will discuss about this point in detail again. Dielectric constant actually decides the factor by which force between two charges changes. Even not ಹೀಗಂದ್ರೆ ಏನಂತೇಳಿ we try to understand. Now, if we compare these two equations, look at this equation 1 and look at this equation 2. I can write from equation 1 and 2. I can write force in medium. Force in medium can be written as idishtu factor in 1 by 4 pi epsilon naught q1 q2 divided by r square. Idishtu 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught q1 q2 divided by r square. This is nothing but force in air or vacuum, isn't it? 1 by 4 pi epsilon q1 q2 by r square. Even now I can write it as force in air or vacuum divided by idishtu. I have written it as force in air or vacuum divided by k. Hagadre force in medium is force in air or vacuum divided by k. So I can now write force between two charges in a medium is less than that in vacuum. Correct? Force in medium is force in air or vacuum divided by k. So force in medium must be less than that in air or vacuum, or we can say force between two charges will be maximum. Force between two charges will be maximum when charges are placed in air or vacuum. When charges are placed in air or vacuum, the force between them will be maximum. Once the charges are placed in the medium, once the charges are placed in the medium, once the charges are placed in the medium, the force between the charges, the force between the charges decreases. Remember this. Once the charges are placed in the medium, the force between the charges is going to decrease. Force between two charges will be maximum only when the charges are in air or vacuum. We'll try to understand this with an example. We'll take up an example at this point. Suppose the force between 2-point charges, the force between 2-point charges separated by a certain distance, separated by a certain distance in air is found to be 81 Newton. See, the force between 2-point charges separated by certain distance in air is found to be 81 Newton. If the two charges are now taken into water of dielectric constant, the two charges are now taken into water of dielectric constant. See, dielectric constant is represented by K and is given by, say, 81 for water. Dielectric constant for water is 81. If the two charges are now taken into water of dielectric constant 81, what is the new force between the charges? It is the new force between the charges. Given the separation between charges in water, separation between charges in water is same as that in air. Same as that in air. Right? This is the question. So go through the question now. It is said that the force between 2-point charges separated by certain distance in air is found to be 81 Newton. So when the two charges are separated by certain distance in air, it is found that the force between them is 81 Newton. However, we can write force in air is 81 Newton. Right? If the two charges are now taken into water of dielectric constant 81, see the dielectric constant of water is given. Dielectric constant of water is given as 81. Right? If the two charges are now taken into water of dielectric constant K, what is the new force between the charges? Ive ಎರಡು charges na water na ತಗೊಂಡೋದ್ಮೇಲೆ force ಎಷ್ಟಾಗ್ತದೆ calculate ಮಾಡಬೇಕು ಅಂದ್ರೆ we need to calculate what is the force between two charges in water. Right? See, we know that force between two charges in the medium is equals to force between two charges in air divided by K. It is given that force between two charges in air is 81 Newton divided by dielectric constant is 81. So force between two charges in medium here is water. 81 divided by 81 is 1 Newton. Observe here, force between two charges when they were in air was 81 Newton, and when the same two charges are taken into water, the force between them becomes 1 Newton. The force in the medium has decreased. Decrease actually force in air was 81 Newton. When it was taken into water, whose dielectric constant is 81, the force became 1 Newton. Andre, the force decreased by a factor 81. The force between two charges decreased by a factor 81. So dielectric constant indicates the factor, dielectric constant indicates the factor by which force between two charges is going to decrease. Dielectric constant indicates dielectric constant indicates the factor by which force between two charges is going to decrease. More is the dielectric constant, more is the dielectric constant, more is the decrease in force. More is the decrease in force. Less is the dielectric constant, less is the decrease in force. ಇಲ್ಲಿ dielectric constant 81 ಅಂತ ಕೊಟ್ಟಿದ್ವಲ್ಲ, suppose ಅದೇ dielectric constant ನಾವೇನಾದ್ರೂ ಯಾವುದೋ ಬೇರೆ medium for some other medium if k is equals to 10, suppose dielectric constant 10 ಅಂತ ಕೊಟ್ಟಿದ್ದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಈಗ what will be the force in that medium? Force in medium is force in air divided by k. So that will be 81 Newton divided by k is 10. So this will be 8.1 Newton. Now the force in medium is 8.1 Newton. When dielectric constant was decreased from 81 to 10, force changed from 1 Newton to 8.1 Newton. ಹಾಗಾದ್ರೆ ಎಲ್ಲಿ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಜಾಸ್ತಿ ಇರ್ತದೋ ಅಲ್ಲಿ ಡಿಕ್ರೀಸಿಂಗ್ ಫೋರ್ಸ್ ಕೂಡ ಜಾಸ್ತಿ ಇರ್ತದೆ. ಫೋರ್ಸ್ ಬಹಳ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. 81 ಇಂದ 1 ಆಗುತ್ತೆ ನೋಡ್ರಿ, 81 to 1. ಅದೇ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಏನಾದ್ರೂ ಕಮ್ಮಿ ಇದ್ರೆ, ಹೀಗೆ ಬರೀ 10 ಇದ್ರೆ, ಡಿಕ್ರೀಸಿಂಗ್ ಫೋರ್ಸ್ ವಿಲ್ ಆಲ್ಸೋ ಬಿ ಲೆಸ್. 81 ಇಂದ 1 ಆಗಲಿಲ್ಲ, ಇನ್ಸ್ಟೆಡ್ 81 ಇಂದ ಎಷ್ಟಾಯ್ತು, 8.1 Newton. So more is the value of dielectric constant, more is the value of dielectric constant, more is the decreasing force. On the other hand, less is the value of dielectric constant, less is the decreasing force. Right? So this is regarding the idea of dielectric constant and force between 2-point charges in medium. So remember, in the medium, the force between 2-point charges is going to decrease, and force between 2-point charges is maximum when the 2-point charges are present in air vacuum. We will continue the discussion on Coulomb's force in our next class, please. Thank you.